Good morning to all. So myself, S.Tamil Selvan from Erode Sengunthar Engineering College, Tamil Nadu, and today I am going to explain about the data structure concept. So basically, data structure concept. So data structures is a way of organizing the data. So before that, first, what is meant by data? So data is a input given to the computer, and there are a lot of data available in the world, but we have to store the data is an essential one, and we have to store the data in a specific order so that we can go for data structures. So the formal definition of the data structure is the way of organizing the data. The way in which we have organized the data is called data structures. So data structures can be classified into two types. So first one, linear data structure, and second one is a non-linear data structure. So in the linear data structure consists of four types: array, stack, queue, and linked list. In the non-linear data structure consists of two types: graphs and tree. In the linear data structure, so all the data have to be arranged in a sequential manner. That is, the data has to be stored one after another. So the best example for the linear data structures are array, list, stack, and queue. And the list is a collection of data can be stored without any principal. So we can store the data as well as we can insert and delete the data at any location in a list. Example for the list is our phone number, list of names, etc. So in the list, we can have a linked list concept. So linked list is a collection of nodes that can be linked together. So basically, the linked list can be divided into three types. So singly linked list, doubly linked list, as well as the circular linked list. In a singly linked list, each and every node consists of two fields, and first one is a data field, and next one is a pointer fields, which is used to store the address of the next node. And the last node of the list can be identified by the null value. That is, the last node, the next pointer of the last node can be defined as a null value, so that that node will be considered as a last node in a linked list. So we can in a single linked list, we can have one forward pointer between the nodes. That forward pointer can be generated by using one concept, that is, and the second node of the address can be stored in a first node of the next field. After storing the address, one forward pointer can be generated. So in a single linked list can be of single pointer, that is forward pointer only. So in a doubly linked list, each and every node can have three fields. First one is a previous field, and the second one is a data field, and third one is a next field. In the previous field is used to store the address of the previous node. That is, when we consider the previous field of the first node will be null, so because there is no more field before the first field. So the first node of the previous field can be nulled, as well as the last node of the next field can be null. So in the doubly linked list, we can have two pointers, that is forward pointer and another one is a backward pointer. And the forward pointer can be generated as like the singly linked list, that is the address of the second node has to be stored in a next field of the first node, means the forward pointer can be generated. And also the previous value of the second node contains the address of the first node. That is, for example, we can have three nodes, means we can have a three nodes inner list, means in the concept of doubly linked list, the previous node of the the previous field of the second node contains the address of the first node, and the address of the the next field of the first node contains the address of the second node. That is right. So next linear data structure is a stack. So stack is a linear data structure, and the data can be stored with the principle of last in first out order. So in the last in first out concept, the both push and pop operations can be obtained in a single place, that is called top value. So, okay. So first of all, what is to be push and pop? So the insertion operation can be identified by the push operation, and the deletion operation is nothing but a pop operation. So both insertion and deletion can be done at the one end, called top value. So these are all the some real-time example and application of the stack. And next one is applications of the stack. There are so many applications. So as like some important application is this one. This is the evaluation of expression. So the evaluation of the expression can be done by the using the stack principle, last in first out. So that for example, so 2 into 10 plus 9 space 6 minus slash is an example for evaluation. So first we have to push the integer values, that is the numbers, into the stack based on last in first out principle. So that the number 2 has to be pushed, and the second one is number 10 has to be pushed, and the third one is we can identify the plus value, that is the addition value, so that and the elements in the stack is been added, that is 2 plus 10 is equal to 12. So next we can identify the values of 9 and 6. So the 9 has to be pushed in a stack and 6 has to be pushed in a stack. And next we can identify the symbol, that is the operation subtraction. So the top two elements, that is 9 minus 6 can be calculated and stored as a 3 in a stack. So next we can identify the element, identify the operators slash, so that the 12 slash 3, the answer is 4, has to be pushed in a stack. So the evaluation of that example expression is 4. So the evaluation of expression is a best example, is a best application of the stack. So we can have some gate questions on stack. So for example, the first question, the result evaluating the postfix expression 10 5 plus 66 slash star 8 minus is So what is the evaluation? So what is output? So that is the first two elements, this 10 and 5 has to be added. So the result is 15, right? So the total explanation in the next slide, that is when first we can have a value that is 10. So 10 has to be pushed in a stack, and we can have another input 5. That 5 also pushed in a stack, and next we can have a input operator plus, so that the 10 plus 5, so the 10 and 5 are added, so the 15 has to be stored, and 15 has to be evaluated, and the next input is 60, so 60 has to be stored in a stack, and next input is 6, the 6 is also stored in a stack, so next one is a slash. So slash, so the top two elements has to be divided, that is 60 by 6, that is equal to 10, so the 10 has to be stored in a stack. So now the stack contains 10 and 15. The topmost element is 10. So next one is a star. Star is a multiplication. So 15 into 10. So 15 multiplied by 10. So output is 150. So 150. So next one is next input is 8. That 8 will be stored in a stack, and the next input can be identified as a minus value, that is subtraction. So 150 minus 8, so that 142. So the 142 is the right answer. So in this evaluation, the option C is the right answer as 142. So the next question is the best data structure to check whether an arithmetic expression has balanced parenthesis is a stack. So the answer is stack, because the evaluation of arithmetic expression and also the balancing the parentheses are the primary applications of the stack. Okay, so the output will be stack. So explanation is these are all the some applications of stack. So this infix to postfix expression, and the evaluation of arithmetic expression, and the balance in the symbols, right? So balance in the symbols are the best application of stack, so that the answer will be stack, right? So next question is which of the following is essential for converting the infix expression to the postfix? So infix expression to the postfix expression formula conversion, we can have an operator stack. So operator stack is a right answer. So because so the infix to postfix expression, so the operators are to be stored in a stack value. That is, so in a concept of infix to postfix conversion, so the operand value has directly go to the output, and the operand and the operator value so has to be stored in a stack. So depending upon the operator precedence value, the operator is popped, so on. So the stack with operator can be, that is the operator stack is used for infix to postfix conversion. So the next question is given an empty stack, after performing push 1 push 2, so that next operation is pop, so 2 is popped, then 3 and 4 are pushed, the next one pop means then 4 is popped, the next one pop means 3 is popped, the next one push of 5 means the 5 is pushed. So the next operation is popped is so next operation is pop, that is 5 is popped, so that the top of the stack is the option is 1, because so first two operations of the push, so that push of 1 push of 2, so that the stack will be this format, and the pop operation can be done in a position of top, so the 2 can be popped from the stack, and the next one push of 3, push of 4, so the 3 and 4 are pushed into the stack, and the next one is pop. So pop means the topmost element of the stack can be popped, that is 4 can be popped. The next operation is also pop, and 3 can be popped, and now only one number 1 is a last element in the stack. So next one is push of 5, so 5 can be pushed in the stack, and next one on the next operation is pop, so that the 5 can be popped from the stack. So finally one so number 1 is only on the stack, so that the output will be 1. So next question is, what data structure would you mostly like to see in a non-recursive implementation in a recursive algorithm? So basically, the recursive algorithm has to be worked by the principle of last in first out. So the output will be stack. So the formally recursive function execution depends on the last in first out principle, so that so it's a last in first out principle is a formal definition of stack too. So the output will be stack. Fine. So next question is, which of the following is not an inherent application of stack? So that is the first option is implementation of recursion. So just now I told you that, so recursion is based on last in first out order, so that will be the wrong answer. And the evaluation of postfix expression is one of the application of stack, so that is not a correct answer. And job scheduling, so job scheduling is a right answer, because so the job scheduling is a best example for queue. That is that in the above 4 options, the job scheduling is only based on first in first out principle, so that will be the application of queue. So next question is, how many push and pop operations will be needed to evaluate the following expression by reverse Polish notation in a stack machine? That is, so the total number of push operation can be calculated by the number of variables. So the total number of pop operation can be calculated by the use of number of operators. So in the above example, we can have the question like that. So we can have totally A, B, C, D, E, so that the 5 variables in the example. So 5 push operations needed for that. And the number of operators are plus star slash, so 4 operators, so that 4 pop operations are needed. So the answer will be 5 push and 4 pop instructions. So I have already told you that pop operations can be identified by the number of variables. So the push up so the push operation can be identified by the number of variables, and the pop operation can be identified by the number of operators. So in all expressions, the push operations depends on the number of variables, and the pop operation depends on the number of operators, right? So in the next and very interest question, that the 7 elements A, B, C, D, E, F, and G are pushed into the stack in a reverse order. That is the starting from G. The stack is popped 5 times, and each element is inserted into queue. The 2 elements are deleted from the queue and pushed back onto the stack. Now one element is popped from the stack. Now what is the popped items? So we can directly go for the explanation part. So the answer will be capital B. Uh, the reason for that, the first step is the stack contains this order G, F, E and D, C, B, A, and this A points the top pointer. And the second step is 5 times stack popped, so that this A can be popped, this B can be popped, C popped, D can be popped, and E can be popped. So that these 5 popped elements are to be stored in a queue. That is, this A value points the front pointer, and this E value points the rear pointer. And the third step is 2 elements is deleted from the queue, that is A and B. So the insert in the queue concept, the insertion can be done in the front end. Sorry, in the deletion can be done in the front end, and the insertion can be done in the rear end. So that the 2 elements deleted from the queue is A and B, and those 2 elements has pushed into the stack. Now the stack contains G, F, A, B, right? G, F, A, B. So that the top pointer points the value B. So now the popped element of the stack is B. So because this B contains the top element, right? Fine. So the next question is the evaluation of Postfix expression. So as like the previous question, so the output will be 100. So how it can be evaluated? So the first operation is 4 plus 6. So 4 plus 6 means, so we can have the numbers as like, first this 2 has to be stored in a stack, and 4 has to be stored in a stack, and 6 has to be stored in a stack. So now the elements in the stack are 2, 4, 6 as like bottom to top. So next we can have a operator as addition. So in that addition, the top 2 values can be added, so that the 4 plus 6 is equal to 10. So the first step is 10. So next operation is next input is star value. So now we can have the stack values are 2 and 10. So we can have an input as a multiplication, so that this 2 and 10 are multiplied, which is equal to 20. So the third operation is 9 by 3, which is equal to 3, and the fourth operation is 3 plus 2, which is equal to 5, and the final operation is 20 into 5, which is equal to 100. So as like our previous explanation, so the so the Postfix expression so can be evaluated by using the last in first out principle. So the numbers we can have, if we can get the numbers from the user, means those numbers can be pushed in the stack. If we can have an operator from the user side as an input, then we can evaluate the first 2 numbers on the stack by with this operator. Okay, fine. So next one is, so what is the value of Postfix expression? So we can have the value of the variable as like A is equal to 8, and B is equal to 4, C is equal to 2, and D is equal to 5. So the Postfix expression is A, B, C, D plus minus and star. So the output is minus 24. That is, the first step is 2 plus 5 is equal to 7, and the second step is 4 minus 7, which is equal to minus 3, and the final step is 8 into minus 3, which is equal to minus 24. That is. So next we can move to Q. So Q is one of the linear data structure in which the data has to be arranged with the principle of first in first out. So first in first out principle has to be followed in a queue. So first in first out principle, with the concept of first in first out principle, the front and rear value can be identified in a queue. So the insertion operation can be done in the part of rear, and the deletion operation can be done in the part of front. Okay, so just please remember that. So the insertion operation can be done in the part of rear, and the deletion operation can be done in the part of front. So these are all the applications of Q. So as like our printer and CPU task scheduling, job scheduling, process scheduling. So these are all the applications of Q, because the first request can be executed first, and the second request can be executed after the first execution. So first in first out order can be followed. So this is a very simple question from GATE. Yeah, Q is a first in first out list. So the next question is, so this is a explanation. So first in first out is a primary principle of Q. That is so next one is the linear list of elements in which deletion can be done from the one end and insertion can be take place by other end is known as Q. I have already told you that the insertion of the data can be done in the part of rear, and the deletion of data can be done in the part of front. Insertion at the rear end and deletion at the front end is a basic principle of Q, right? So so the next question is, how many stacks are required to implement a Q? So the output will be 2. So why? Because so one stack is used to perform insertion operation, and another one stack is used to perform a deletion operation. So the inserted element can be stored in a one stack, and the deleted elements can be stored in another stack. So that the when we are implementing a queue, we can have the stack or the 2. Okay. So next question is, at a hill station, the parking lot is one long driveway snaking up a hillside. Cars drive in and park right behind the car in front of them, one behind another. So this is a best clue for identifying the answer. One behind the another. So one behind the another means that is so that the invisible answer is Q. So the output will be Q. Okay. So a car can't leave until the car in front of it have the lift. Okay. So the second car has to be waited until the first car can be removed. So the first in first out principle has to be followed in that concept. So the answer will be Q. Fine. So next one is Next question is, how many queues are needed to implement a stack? So total number of queues is 2. Why? Because one queue is for inserting an element and another queue is needed for deleting an element. That is, one queue is used for push operation and another one queue is used for pop operation. So the pushed element has to be stored in one queue, and the popped element has to be stored in another queue, so that we can have two queues for implementing a stack. Fine. So next one is a non-linear data structure. So in a non-linear data structure, the data are arranged in a hierarchical manner. So the data is not arranged in a sequential manner. So the best example for the non-linear data structure is tree and graph. So so this is a example for the hierarchical data structure. Fine. So all the data cannot be handled in the same level. So we can have some precedence to the data, so that the data has to be placed in the various levels. Okay. So so that in the nonlinear data structure, uh, all the data are stored in a hierarchical manner. So this is a example for tree. So tree contains the root node and edges. So the edges is a it is a direction between the two nodes, and the parent node, children nodes, leaf nodes, and siblings are the part of trees. So the siblings is nothing but a number of nodes can have same parent called siblings. So that in this above example, A and B are the siblings. Why? Because A and B are having the same parent Q. So that A and B are the siblings. So this so the children's or the node can be derived from the parent called children. So the leaf nodes is a every node will be defined as a leaf node. Why? Because uh, the node can have no children is called a leaf node, right? So each and every node may or may not contain the children. So a node can't have a children called a leaf node. Okay. So next one is a graph. So graph can be divided into two types. First one is a undirected graph, and second one is a directed graph. So in a directed graph, there may be a chance for cycle. Cycle means the starting and ending node are the same. In an undirected graph, there is no direction. There is no forward and backward direction in a graph. Fine. So the social media is a best example for application of graph, right? So in a gate question, the height of the tree is the length of the longest route to leaf path in it. The maximum and minimum number of nodes in a binary tree of height 5 are so 63 and 6 respectively. Why? Because in the binary tree, each and every node can have maximum 2 children. So either there is no children, or only one children, or maximum of 2 children, called a binary tree. So so the formula for calculation, so the maximum number of nodes is equal to 2 power h plus 1 minus 1. So h is a height value. So height value, so 2 power 2 cap 5 plus 1 minus 1. So 2 power 6, which is equal to 64, minus 1 is equal to 63. So minimum number of nodes are the h plus 1. The formula for minimum number of nodes is h plus 1. So we have already known that h is equal to 5. So 5 plus 1 is equal to 6. So the output will be 63 and 6. Okay, fine. So next we can go for linked list. So linked list, I have already told you that. So linked list is a collection of node with linked together. Uh, so in that linked list, we can have the three types: singly linked list, doubly linked list, and circular linked list. In a singly linked list, each and every node has only two fields. First one is a data field, and another one is a next field. So that next field is used to store the address of the next node. So the last node can be identified by the null value in the next field in a singly linked list. So in the next one, it's a doubly linked list. So in a doubly linked list, we can have three fields in each node. So first one is a previous field, and second one is a data field or input field, and third one is a next field. So in the previous field contains the address of the previous node, and the next field contains the address of the next node, right? So the first node, the previous field of the first node can be null, because that will be the first node. There is no more nodes before that. Okay. So and the last and the next field of the last node can be identified by the null value, so that that will be the last node in a list as like single linked list. So one important note is, so the head is a pointer. It is used to point the first node in a list. So hope you remember that. So head is a pointer. It is used to point the first node in a list. So this is a best example and best application of array and linked list. So first one is a array. So the memory can be allocated continuously in an array. So in a linked list, the memory cannot be allocated as a continuous one. So we can take the memory from anywhere. So the array is a static one, and linked list is a dynamic one. A linked list is a linear data structure, but the elements is not stored in a continuous location. So it is a best example. So this is a best one in a linked list when compared to array. So we can go for previous slide. So this pointer, this second pointer, this first pointer, and sorry, this first memory location and this second memory location can be linked together by the use of pointer. So basically there are three types of pointers: singly linked list, basically the three types of linked list: singly linked list, doubly linked list, and circular linked list. So first we can go for singly linked list. In a singly linked list, a sequence of elements in which every element has the link to its next element. So there is only one pointer, that is only one forward link between the nodes. That is, so each and every field consists of two fields. Each and every node consists of two fields, that is data and the next field. So data field is used to hold the element, is used to hold the data, and the next field is used to hold the address of the next node, right? So in the below example, so this 100 is the address of second node, so has to be stored in the second field of the first node. And this 300 is the address for the third node, has to be stored in the address of the next field of second node. So this is a principle has to be followed in a singly linked list. Fine. So there are in a single linked list there are many operations. So in this class we can have the primary operations like insertion, deletion, and display. So the best advantages of the linked list over array is a insertion at the middle value. So in an array concept, insertion at the middle value is a toughest one. Why? Because the when we insert a single value in the middle means it can affect all the values after that. So this insertion can be done in the middle. Insertion can be done easily in the middle. Okay. So in a linked list, insertion can be done in a three place. So first one is insertion at the beginning, insertion at the middle, and the insertion at the end. So insertion at the beginning means, so uh, this is an primary list. So when we have to insert a node from the beginning of the list means, so first we have to create a node. uh, we have to create a node in the name of new with node structure. So then next we have to allocate the input to the node. So the new node uh, can have an input of 5. And so I have already told you that head pointer is used to point the initial node or first node of the list. So the head pointer is allocated to the newly created node, so that the coding is new of next is equal to head. So the address of the head node, so address of the head node is capital A, so has to be allocated in the new of next field, so that the forward pointer can be generated. So that newly created node has to be named as head value, so that sorry, why? Because the each and every head pointer can be pointed as a first node in the stack, so first node in the list. Okay, sorry, first node in the list. Fine. So next one, insertion at the middle. So insertion at the middle is a very easy process in the linked list. Why? Because so first we have to identify the position where we going to insert. So as like first we have to create a node with the node structure uh, as named as new, and we have to allocate the input to the new node, and we have to assign the temp value to the head position, so that the temp value, so the in the concept of insertion at the middle, the temp value has to be placed the uh, has to be placed the for example, if we have to insert the node at the fourth position means the temp value has to be placed in the third position. If you want to insert a node at the seventh position means the temp value has to be placed in the sixth position. Okay. So this is a coding level for insertion at the middle. So it is very easy, so that the temp value has to be placed in this one. So the address of the new element, first step is address of the new element has to be placed in a temp in a next field of the temp value. Okay. So that is address of the new node has to be placed in a next field of the temp value, so next field of the temp node. Okay. So that the new is an address, so the new has to be stored in a next field of the temp node. Okay. Fine. So next one is So next step is, so uh, the new node, so the temp of next field has to be stored in a new of next, so that the d value, so d is the address of the next node, that address has to be stored in a new of next. Okay, fine. So next one is a insertion at the end. So insertion at the end is very easy. Why? Because first we have to create a node with the name of new, with some node structure. So next we have to allocate a null value in the new node of next field, so that that can be identified as the last value, sorry, last node of the list, right? So fine. So next step is, um, so in the above logic, so that's a fourth element will be the last node of the list. So fine. So here, so this null value, this fourth element, uh, uh, the next field of fourth element is null value. This null value has to be assigned as a new of next field. Okay, so new of next field. After that, the address of new node has to be stored in a fourth node of next field. So that's all. Fine. So next one is a deletion operation. So as like insertion, the deletion also can be done in the three places of list. So first one is a deletion at the beginning, next one deletion at the middle, and third one is a deletion at the end. So first one is a deletion at the beginning. So it is very simple. So when we want to delete a first node, the only one step has to be followed. The head pointer has to be moved to the next second pointer, I mean second node. So that I have already told you that the head pointer is used to point the first node of the list. Okay, so that the first node can be deleted. So this so in this example, the head node is to be moved to second node, so that the first node has to be deleted automatically. Okay, second one. So now next one is a deletion at the middle. So it is also very simple. Why? Because so this first we have to get the input from the user, that is which node can be deleted. That input can be retrieved from the user. For example, if we want to delete the third node in the list means, so the address of the uh, address uh, of the deleted node or deleting node D has to be stored in the previous node. That's all. So this D has to be stored in this next field of B node, so that this forward pointer can be generated. So why? Because the next field contains the address of the next node. So this B node, the second node of address field contains, for example, if this field contains the D means, so the forward pointer can be generated towards D, so that this third element can be deleted automatically. Okay, fine. Next one is a delete at the end. So it is also very simple. Why? Because first we have to identify the last element, last node in the list. So by the use of this while loop, we have to identify the null value which where it is stored in the next node. Fine. So this fifth node, so next to pointer, so next to point contains the null value of the fifth node. So this can be identified and this can be deleted. So if we delete this node, then automatically this field, this fourth node of next field will be assigned as a null, because there is no more address. If we deleted this e node, automatically this e went out, so that this fourth node of next field can be assigned as a null value. So it is very simplest one. So next one, so next one is a display. So normally we can easily display the list value by the use of any for loop and any while loop as right. So circular linked list concept. So last node is connected to the first node. So there is no more beginning, there is no more end node in the circular linked list. Okay, fine. So so circular linked list contains no starting node and no final node, because it is circular. It is in a circle format. Okay, fine. So in a circular linked list contains the singly circular linked list as well as the doubly circular linked list. In a singly circular linked list is a contains the single pointer between the nodes. In a doubly circular linked list contains the double pointer, that is forward and backward pointer in between the nodes. Fine. So gate questions on the linked list is in a circular linked list, which one of the following answer is correct? The components are all linked together in some sequential manner. There is no beginning and there is no end, and components are arranged hierarchically, and forward and backward traversal within the list is permitted. Right. So there is no beginning and there is no end is a right answer, because in a circular linked list, I have already told you that we cannot identify the initial and the final node in the list. So this is our explanation. So since the last node is connected the first node, so there is no beginning and end node. Fine. So next one is next question is the linear collection of data elements where the linear node is given by means of pointer is called linked list. So the linear collection of data elements where the linear node is given by means. So is given by means of pointer. So the two nodes can be connected by the use of pointer called a linked list. This is a formal definition of linked list. So linked list contains the set of nodes in a sequential manner, and the nodes can be assigned or can be connected with the pointer is called a linked list. So the answer will be linked list. So in a linked list concept, the nodes are connected to other node by using pointer. So either using double pointer or single pointer or does not matter. So each and every node is connected with that by the use of pointers called linked list. Right. So the next one is a variant of linked list in which the last node of the list points to the first node is called, we can easily say that it is a circular linked list. Why? Because so the first node and last node can be connected together, right? So there is no more beginning and there is no more end, there is no more initial node, there is no more final node. So we can't say that like that, right? So so the answer will be easily identified as a circular linked list, right? So why? Because so the last node is connected to the first node. So we can't say that it is an initial node and it is final node and so on. That is okay. So thank you very much for your patient listening, and Hope we'll meet you again. Thank you.